Hello, welcome to the long-awaited section 5.2 where we get to divide polynomials with long division. I know you're very excited. So in section 1 we used exponent rules and we divided monomials. So we did things like, like 3x squared y to the fifth divided by xy, and we knew that that became 3x y to the fourth. Well, today we're going to extend that a little bit to talk about polynomials, and we're going to talk about long division, and we're going to talk about something called synthetic division. So when we get to synthetic division, I'll give you a better definition of what that is. But we're going to start out when I divide a polynomial, and this is super important, by a monomial. So when I divide a polynomial by a monomial, this is super easy. I actually don't need long division or synthetic division, because each term will be individually divided by the denominator. Okay, so there's my original expression that we want to simplify, and you're just going to write it out as three separate fractions, right? Because this is a common denominator that's common to each of the fractions. So this is equivalent to this. So when the denominator is a monomial, meaning there's no adding or subtracting, it's just a single term, I just write each fraction out separately. And then we simplify. So 5 divided by 5, we know that that will be 1. A squared divided by a will be a to the first, and b divided by b will just be the number 1. And so that term becomes a. 15 divided by 5, that's 3, and it's negative 3 because of the subtraction. A divided by a, those divide out to 1. B cubed divided by b is b squared. And then here we have 10 over 5, which is 2, and it's plus 2 because of the addition. A cubed divided by a is a squared, and b to the fourth divided by b is b cubed. And so that would be our final answer. So when you're dividing by a monomial, all you have to do is apply the exponent rules that we learned in section 1. So I want you guys to try this one for me. Okay, your answer should have been B. And hopefully you remembered to write it out as three separate fractions and use your exponent rules. It's super important that you pay attention to what you're dividing by, what your divisor is. Because when it's a monomial, you just need to use exponent rules. But it's easy to confuse the different kinds of division if you're not paying attention to the kind of divisor that you have. All right, so let's look at a little bit of review of long division with just numbers, okay? So if I'm going to take 8,764, we call this my dividend. That's the vocabulary. And we're dividing it by 4. This is my divisor. And remember, the answer we get is called the quotient. So I'm taking 8,764 divided by 4. So we ask ourselves, how many times does 4 divide into 8? Well, twice, right? So we write the 2 over the 8. Then 2 times 4 is 8. We write that here. And then we subtract, and they didn't write the subtraction sign. 8 minus 8 is 0, and then we bring down the 7. So now I have the number 7. How many times does 4 go into 7 evenly? Well, only once, right? 1 times 4 is 4. 7 minus 4 is 3. We bring down the next number, which is the 6. How many times does 4, our divisor, go into 36? 9. So we write the 9 over the 6. 9 times 4 is 36. We subtract, and we get 0. We bring down our last number, which is 4. How many times does 4 go into 4? Well, once, so we write the 1 over the 4. 1 times 4 is 4. 4 minus 4 is 0. All of these are basically that same process. Notice that in the second example, our divisor is a 3-digit number. So it's not going to go into 4 or 45. I have to ask how many times does it go into 453, the first 3 digits of this number. And the answer is twice. So 2 times 216 is 432, and I subtract that. We get 21, and then we bring down the 6. 216 goes into that once. 1 times 216 is 216, and we subtract and get 0. So notice that both of these have no remainder. So that means that 216 is a factor of 4,536, and 4 is a factor of 8,764. Notice in the last example, as I do all of my division, I end up with the number 19, and I have no other numbers to bring down. So we say that the remainder is 19, Or we could write this as 19 over 31. So the quotient would be 17 and 19/31. Well, we're going to basically use this same process when we do long division with polynomials. So stick with me here, okay? So here, notice that I have a trinomial, and this time I'm dividing by a binomial. Not a monomial, but a binomial. So that means I'm going to have to use a different algorithm. This time we're going to use long division. So I'm going to look at the first term of my binomial, x, and ask, how many times can x squared, the first term of my polynomial, be divided by x? Right? X squared divided by x is what? Well, it's x to the first power, right? So x squared divided by x is x. So I write that above the x term. Then what I do, just like with the long division, is the thing that I write up here, which in this case is a variable, I multiply it by my divisor. So I'm going to take x times x minus 5, and that's going to give me x squared minus 5x. And I'm just going to write that here directly below this part. And then I'm going to subtract. I suggest that you write parentheses so that you remember you're subtracting both terms. X squared minus x squared is 0. Negative 2x minus negative 5x is positive 3x. And then we're going to bring down our next number, negative 15. And then we're going to repeat. I look at the first term of my divisor and the first term of what's in here inside my dividend. So I ask myself, 3x divided by x is what? Well, it's 3. It's a positive 3. So I'm going to write plus 3 up here. And notice what happens when I take 3, right, this 3 times my divisor of x minus 5. I get 3x minus 15. And I write that underneath here. And again, parentheses, because I'm going to be subtracting. So 3x minus 3x is 0. That should always happen if you do it correctly. And in this case, I have negative 15 minus negative 15, which is also 0, right? So that means that x squared minus 2x minus 15 divided by x minus 5 equals x plus 3. And just like if we went back to the previous slide, my answer here means that if I take 21 times 216, I would get 4,536, right? Same way with this long division algorithm, if I were to take x plus 3 times x minus 5, right, my quotient times my divisor, I would get my dividend. Okay, so I want you guys to try this one, all right? All right, your answer here should be ax plus 2, and I'll show you the work. This is what your process should look like. Okay, let's look at this example. This is a standardized test example, but it's asking us here, which expression equals this? A squared minus 5a plus 3 times 2 minus a to the negative 1. Well, remember that 2 minus a to the negative 1 is like a reciprocal because of the negative x. So this is actually a division problem. A squared minus 5a plus 3 divided by 2 minus a. So we're going to set up our long division. Notice how I wrote my divisor here as negative a plus 2. That's the same as 2 minus a. It's just arranged so that the variable comes first and the constant comes second. And that will probably be an easier way to write it so you don't get confused. So negative a times what would give me positive a squared? Well, that would have to be a negative a, because negative a times negative a is positive a squared, and I want these to subtract to 0. Negative a times positive 2 is negative 2a, and remember I'm always subtracting here. A squared minus a squared gives me 0. Negative 5a minus negative 2a gives me negative 3a, and then we bring down the plus 3. Negative a times what is negative 3a, or negative 3a divided by negative a is what? Well, positive 3. Positive 3 times negative a is negative 3a. 3 times 2 is 6. And again, parentheses and subtraction. Negative 3a minus negative 3a is 0. 3 minus 6 is negative 3. And now I have no more terms to bring down, so this negative 3 is my remainder. So what we're going to do is we'll write plus negative 3 over negative a plus 2. Or another way to write it, as you can see over here, is what it looks like in D. Negative a plus 3, and instead of writing plus a negative, they just made this a subtraction right here. And instead of writing negative a plus 2, they wrote 2 minus a. Same thing. So D would be your answer in this. All right, I want you to try this one. Your answer should have been B. And there is the work to show how to get there. Last but not least, today we're going to talk about synthetic division. And I actually think you guys will like synthetic division once you learn the process, because the cool thing about synthetic division is we get rid of the variables and we just kind of deal with the arithmetic of the numbers, and we put the variables back in at the end of the process. So step 1 is to write the coefficients of the dividend in descending order. So we want to go from highest degree to lowest degree. And then we start bringing our coefficients down. And we basically multiply and add until we get to the last column. It's easier to show you this with an example, so let's just do that first. So we're going to use synthetic division to find this quotient, okay? So we need to make sure these are in order. X cubed, 4x squared, 6x, negative 4. So from largest degree to smallest degree. And then we're just going to write the coefficients. So 1, negative 4, 6, and negative 4. Just the coefficients of the dividend. Now, we say, okay, what makes my divisor, which in this case is x minus 2, what makes that 0? Well, positive 2, right? So this positive 2 that I just got here is what they're writing right here. Now, watch what I do carefully. We can only do synthetic division when this leading coefficient is 1. So I bring the first 1 down, always. Then I do 1 times 2, which is 2. Negative 4 plus 2 is negative 2. Negative 2 times 2 is negative 4. 6 plus negative 4 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. This last number here is always your remainder. So in this case, there's a remainder of 0, which means that x minus 2 is a factor or divides evenly into x cubed minus 4x squared plus 6x minus 4. So the cool thing is now that we have these numbers, I know that I did something that was x cubed divided by x to the first, right? I know that x cubed divided by x is x squared. So that's going to be the degree of my answer. So I just have to rewrite this as 1x squared minus 2x plus 2. And since there's no remainder, this would be my final answer. That is my quotient. So you guys try the same thing with this one. Okay, your answer here should be dx plus 7. And there is what the synthetic division looks like. Remember, this means that x squared plus 8x plus 7 divided by x plus 1 equals x plus 7. So if we think about what division means, that means that x plus 7 times x plus 1 should give me x squared plus 8x plus 7, which it does. Okay, last example. Remember I told you that synthetic division only works when the leading coefficient, and I think I told you the wrong thing actually earlier, the leading coefficient of the divisor has to be 1. This needs to be a 1. So what we're going to do is we're going to rewrite it so that it does have a leading coefficient of 1. So in order to make that happen, I have to divide everything by 2 in the numerator and the denominator. So that's how we got to here. We divided everything by 2, right? So instead of having 2y minus 1, I have y minus 1/2, and everything in my numerator was also divided by 2. So we're going to set up our synthetic division just the same way that we did before. So what we're dividing by is y minus 1/2. So my r right here is positive 1/2. And these are the coefficients of my numerator. So I bring down the 2. 2 times 1/2 is 1. Negative 3 plus 1 is negative 2. And so on. Again, my remainder is 0. And then, since my original polynomial started out as y cubed, my depressed polynomial is 2y squared. Try this.